Patty Simpson with Simpson Math. In this video, we're going to look some more at logarithms. Remember that a logarithm is just looking for an exponent. We have log base b of x is equal to y. That's the same thing, or it's equivalent to the base of b raised to that y power is equal to x. So here I have log of 100. Notice that my base is missing. When we don't write a base, the base is understood to be 10. So anytime we just have log with no base written, there's an understood 10 here. This is the base of 10. So I'm just asking 10 to what power equals 100. So 10 times 10 is 100. So 10 to the second power equals 100. So log of 100 is just equal to 2. It's a fancy way of saying the number 2. Here I have log of 1,000. Again, there's no base written, so it's understood to be 10. 10 to what power equals 1,000? Well, 10 times 10 is 100 times 10 is 1,000. That's equal to 3. It's really nice because you really can just count the number of zeros that are there, and that tells you what power you're raising 10 to. Here, I have log of 1. Again, there's an understood 10 in my base. So 10 to what power equals 1? We learned in a previous video that anytime my argument is 1, my exponent is 0. Because 10 raised to the 0 power is equal to 1. Log of 10 to the 8th, my understood base is 10. So 10 to what power gives me 10 to the 8th? Again, in a previous video, we looked and saw when their bases were the same, their exponents are the same. So it makes sense that 10 to the 8th power is equal to 10 to the 8th. So here my bases are the same, my exponents are the same. This one is in exponential form. I have 10 raised to the log base 10 of 53. Now log base 10 of 53 is not a pretty number. It doesn't come out just nicely. But we saw in a previous video that when their bases are the same, their arguments are the same. So whatever that number is, somewhere between 1 and 2, some decimal between 1 and 2, when I take 10 and raise it to that 1.4-ish number, I'm going to get back out 53. So when their bases are the same, their arguments are the same. So when I don't write a base, it's an understood base of 10. Here, I also have a log, but notice this one doesn't say log. Instead, it says ln. That is the letter L for log. This one is a natural log. So, originally in French, so logarithmic natural or something, my French is no good, but the L is followed by the logarithm is followed by that adjective of natural. We would say natural log, but in other languages, they put the adjective afterwards. So this is the natural log. In this case, we're talking about that natural number of e. So my base here is understood to be Euler's number, that e that we've talked about in the past. That's about 2.71-ish. So here I'm asking myself, e raised to what power gives me e? Well, e raised to the first power gives me e. Again, here I have the natural log. So this natural log, I have an understood base of e. And I'm asking e to what power gives me 1 over e to the 7th. When I see my base in the denominator, I immediately think to myself, I'm going to have a negative exponent to reciprocate it. Then e is being raised to the 7th power. So e to the negative 7 would give me 1 over e to the 7th. The negative would reciprocate it, and then that 7 is there. So there's just an understood base of e. The natural log of 1 over e to the 7th is just equal to negative 7. The natural log of 1, again, there's an understood base of e. E raised to what power gives me 1? Well, any non-zero number raised to the 0 power equals 1. So when 1 is in our argument, it's always going to be equal to 0. Here, I have my e raised to the natural log of 3. You know, that's just barely over 1 because e is about. This natural log of 3 is a little over 1 because natural log of, it has a base of e raised to the little bit 1.1-ish would give me 3. So this is 1.1-ish. Well, e to the 1.1-ish is going to give me back that 3. When their bases are the same, their arguments are the same. Here I just kind of have a fun problem to let you know that these are just numbers. This is just a number minus this is just a number. We're going to figure out each little piece of this. So what is the logarithm? What is the log of 10,000? My base is an understood 10. So 10 to what power gives me 10,000? Well, it's 1, 2, 3, 4. This is just a fancy way of saying 4. My kids on their 4th birthday, when somebody asked them, how old are you? Instead of saying I'm 4, they might have said, I'm log 10,000, which just means 4. Minus natural log of e to the 4th. It's an understood base of e. So e raised to what power gives me e to the 4th? Well, when their bases are the same, their exponents are the same. So that 2 is just equal to 4. This is a fancy way of saying 4. So maybe when my kid turned 4 and somebody asked him how old he is, he might have said, I natural log e to the 4, because that also is equal to 4. Then this number minus that number is just equal to 0. So here we have again, we're evaluating logs. When we have the word log and no base, it's an understood base of 10. And this natural log has an understood base of e. Math made simple at Simpson Math. Thanks for watching.